In this video, you will learn how to write and solve compound inequalities. A compound inequality is defined as an inequality joined by and or. Now the top example is an example of an and inequality, and the bottom one is an example of an or inequality. Now we're going to talk about and inequalities. There's two ways to graph and inequalities. The key part of this is that and inequalities are the intersection of two inequalities. So, for example, if I were to graph the first one, I have x is greater than -3. So if I were to graph that, I would go to -3 and put an open circle since it doesn't have a line underneath. And since the x is first and it's pointing to the right, I know I'm going to start to go to the right. However, we're going to not go the entire way to see where the intersection is going to happen, because in my second inequality, I have x is less than or equal to 1. So that would have a closed circle at 1, because there's a line underneath. And since x is first and it's pointing to the left, I can start to shade to the left. Now we can see, looking at that these two inequalities are going to run into each other and form this whole center part is going to be what's highlighted. So if we want to graph, our full graph for the inequality should be we have an open circle at -3, a closed circle at 1, and then we're shading the middle because it's the intersection of these two inequalities. Now, if you see something like you have below, you can also graph it in the same order. We know that because x is in the middle, you are going to shade the middle. So if I want to graph this, from the first part, I know that I have an open circle at -3. So I can put my open circle at -3. I also have a closed circle at 1. I'm going to put a closed circle at 1. And then we're shading the middle because, again, x is in the middle. So I would shade in between the two. Now we can see that looking at this, these two graphs are the same thing. It's just different representations of them. So in this slide, we're going to practice graphing compound inequalities. First, let's deal with the top two, which the first one is like our original methods. This is like version 1 that we saw on the previous slide. If we want to graph the two inequalities separately. And remember, because this is and, we are looking for the intersection or the middle. So you're shading in between. So if I wanted to graph, I would do this piece by piece. However, we're not going to graph the whole thing right away. So if I have x is greater than -3, I'm going to find -3. I'll put an open circle at -3 and start to shade a little bit to the right because my arrow is pointing to the right. Then, for the second part, I have x is less than or equal to 4. So I can find 4. I'm going to put in a closed circle because there's a line underneath. And since it's pointing to the left, I'm going to start to shade to the left. Now we can see where these two inequalities are going to intersect each other. So that means I can put an open circle and a closed circle and then shade the middle. For the next one, we're going to follow the same process of graphing each part of the inequality. So first, if I want to graph x is less than 5, since there isn't a line underneath, I can put an open circle at 5, and my arrow is pointing to the left, so I can shade to the left. For the second part, it gives me that x is greater than or equal to 0, so I can put a closed circle at 0, and since it's pointing to the right, I can shade to the right. Now we can see that these two lines are going to intersect, so my full graph is shown here. Now, technically, we could rewrite these if we want in the second format. So, for example, for the top one, we know that x is between -3 and 4. Our arrows are both going to point to the left. So it has an open circle at -3, so I can leave it that way. And there's a closed circle at 4, so I can put a line underneath. For the second one, I know that I have 0 and 5 with x in the middle. I have a closed circle at 0, so I'm going to put the line under my symbol. And I have an open circle at 5, so I'm going to leave it with just the symbol. For the last two examples, this is method 2, or the second type of inequality modeling that we talked about. With this, we're going to graph each number and then shade the middle. So if I want to do that, I first want to graph the first part. So I have a 4, and there's no line underneath. We're not going to worry about drawing arrows yet because we know it's always going to be shading the middle. So I can find -4, and I put an open circle. For the second half, I have is less than or equal to 4. So I can find 4 and put a closed circle because there's a line underneath. And now I'm going to shade the middle where the x is. So I can shade the middle. So I have my full graph as shown here. In our last example, we're going to have first find -3, and we're putting a closed circle there since there's a line underneath. Then I have a 1, and it doesn't have the line underneath, or it's not equal to, so I can have an open circle at 1. And then lastly, since x is in the middle, I am going to shade the middle. So I have my full graph as shown here. So if I want to solve this and inequality in our first method, where they are written separately, we have to solve each inequality separately. So if I were to do that, the first one I have is n minus 1 is greater than -2. So to solve for n, I would add 1 to both sides. So I'd have n is greater than -1. Now if I graph that, I'm going to put an open circle at -1 because my symbol doesn't have the line underneath because it doesn't include greater than. And I'm going to start to draw my arrow, and we see that since the variable is first and it's pointing to the right, I can start to shade to the right. Okay. However, because it is an and inequality, we know we are shading the middle, so we're going to wait to shade the whole thing. To solve the other inequality, I would have to divide both sides by -2. And remember, when we divide, because this is a negative number on the bottom that we're dividing by, your sign is going to have to flip. So if I graph, I'll have n, -6 divided by -2 is 3, and my sign switches from being originally greater than to now it will be less than. So if I want to graph this inequality, I'm going to have an open circle at 3, and since my inequality symbol is pointing to the left, I can start to shade to the left. Now we can see that these lines are going to intersect with each other, so our final inequality is going to be the two open circles with the middle shaded. Now we can rewrite this using what I have from up here and knowing it's an and inequality, so your answer could be n is greater than -1 and n is less than 3. And you can also rewrite it if you would like as -1 is less than n is less than 3. So for our next inequality, if we wanted to graph, we would first have to take our 8 plus x and solve it separately. This is our first representation. So if I were to do that, I would have to subtract 8 from both sides, which gives me that x is less than 6. So if I were to graph this, I can put an open circle at 6 on the graph, and since my x is first and the inequality is pointing to the left, I can start to shade a little bit to the left. Now for the second one, I would have to divide both sides by 5. And when I do that, I get x, negative 4 divided by 5 is negative 8. And since this is a positive on the bottom, we don't need to flip. We only do that when the bottom is negative. So my symbol is going to stay facing in that direction. So if I were to graph, I can put an open circle at negative 8. And again, x is first and it's pointing to the right, so I can start to shade to the right of it a little bit. And we can see that these two inequalities are going to collide. So we can put an open circle at negative 8, an open circle at 6, and then shade the middle of these two. And if I wanted to write our answer, I can either use my two inequalities with the and, so x is less than 6 and x is greater than negative 8, or I could rewrite it as negative 8 is less than x is less than 6.
Now, in order to solve an and inequality, you want to still isolate the variable, so we get it in that form like we had in the last slide. So we're still going to repeat the same steps we would just like we were solving an equation. However, whatever you do to one part of the inequality, you have to do to every single part. So for this example, if we want to get t by itself, I would have to subtract 4. Now, since I'm subtracting 4 from the center, I'm going to subtract 4 from every part. So I'll get negative 9 minus 4 becomes negative 13. Carry my inequality symbol. This becomes just t, and carry the inequality, and then I get 10 minus 4 gives us 6. Now this gives us the inequality we're going to graph. So we're going to have an open circle at negative 13, an open circle at 6, and I'm shading in between.
In our next example, we have another one of our method 2 types of inequalities where we want to solve to get that middle part or the middle variable, so b is by itself. Now since the 5 is next to the b, we're implying that we're multiplying, so I'd have to divide by 5. Now if I divide by 5 in the middle, I'm going to do it to all three parts. So I divide by 5, divide by 5. When I do that, negative 25 divided by 5 is negative 5, is less than 5b divided by 5 is b, and 45 divided by 5 is 9. So now if I were to graph these, I have negative 5 with a less than, so it's going to be an open circle. So I can find negative 5, put an open circle. Then I have a 9 with a less than, so it's going to be an open circle at 9. And then the middle is this value of b, so I'm going to shade the middle of our graph. So we have our final answer is negative 5 is less than b is less than 9. In our last example, we have negative 5 plus 3a in the middle. Now, if I focus just on wanting to get that by itself and I were to pretend that the two other parts aren't there, the first thing I would do is I would add 5 to cancel out the 5. Now, whatever I do to the middle, I have to do to all three parts. So I can add 5 to all three sections. Now, when I do that, you're left with negative 27, the 5's cancel, is less than or equal to 3a, is less than negative 5 plus 5 cancels, So it becomes just 0. Now, if I want to keep going and I want to solve to get the a by itself from the 3a, this is implying that we are multiplying, so I'd have to divide by 3. And again, I'm going to do that to all 3 sections. So I divide all 3 parts by 3. So I get negative 27 divided by 3 is negative 9 is less than or equal to a is less than 0. So if I were to graph that, first I have the negative 9 with a less than or equal to. So I'm going to have a closed circle at negative 9. Then if I look, I have is less than 0. I'm going to put a closed circle, or an open circle, sorry, at 0, because there isn't a line underneath. And then finally, I'm going to shade the middle. So our answer would be negative 9 is less than or equal to a is less than 0. Lastly, let's talk about special cases of the compound and inequality. Compound and inequalities include the intersection only. So it's where the two lines cross. So for the first one, if I'm looking at x is greater than 3, I would graph, have an open circle at 3, and I would shade to the right. For the second part, I have x is less than or equal to negative 5. So I can put a closed circle at negative 5, and I would shade to the left. Now, since if we were to look at these lines, there's no intersection, this would be what we would call no solution. For the second example, I have x is greater than 2, so I can put an open circle at 2, I would shade to the right. And the second part, I have x is greater than or equal to 3, so I can put a closed circle at 3, and I can shade to the right. Now, since I'm only talking about the part where it intersects, it's only where the red and the blue cross, which would be essentially the graph of the blue. So my answer here is just one inequality, and if we're to write it, in this case, it would be x is greater than or equal to 3.